Hello viewers, welcome to the series You the Oracle Expert, where you practice Oracle database administration and UNIX using Oracle VirtualBox virtual machines and start your journey towards becoming an expert Oracle DBA. In the previous video, we learned about how to install VirtualBox guest editions, how to create a shared folder, how to create a virtual machine snapshot, and how to restore and remove a virtual machine snapshot. In this video, we are going to learn how to add a new virtual disk to a virtual machine, LVM or logical volume management to create physical and logical volumes, create a file system using LVMs. Please note that you don't have to be an expert in VirtualBox, or you don't have to be a master in LVMs to create physical logical volumes or manage file systems at UNIX level, but an understanding on these topics will definitely help you to build a strong foundation, and going forward, this knowledge will help you with the real DBA experiments that we are going to perform in our virtual environments. So let's start today's tutorial to learn how to add a new virtual disk to a virtual machine. So let's start by adding a few virtual disks to our virtual machine, that is the VM Linux 1, and increase its storage capacity. It's always a good idea to create a snapshot before making any changes like this. So we'll take a snapshot first. Take snapshot 1. Okay. I'll go to settings, storage, select the SATA controller, click on the add icon, create VDI, next, dynamically allocated, next. The location will be our D drive and the folder VM Linux 1. Under that, we'll create the file with a name VM Linux 2.vdi, and the size will be 1 GB in size. Create. Then again, we'll add the second disk, VDI, next, dynamically allocated. The name will be free, size will be 2 GB in size. Create. Now the third one, create VDI, next, dynamically allocated, next. The name will be VM Linux 4.vdi, save. The size is going to be 10 GB in size. Create. And we created these three data files, virtual disk files, VM Linux 2, VM Linux 3, and VM Linux 4. Now we'll add these files to the virtual machine. Select the first one, that is the VM Linux 2, choose. Again, add the second one, that is the VM Linux 3, choose. And the third one, that is VM Linux 4, choose. And we added these three new virtual disks. First one is 1 GB in size, second one is 2 GB in size, and the third one is 10 GB in size. And these are all dynamically allocated. And the reason behind my selection of dynamically allocated is we'll be able to extend the size of these virtual disk files later on if needed. If you create the disks as fixed size, you will not be able to extend the size of those virtual disk files, although it is not a limitation, because even if you are not able to extend the size of an existing disk file, virtual disk file, you will always be able to add a new virtual disk file if needed. Now click OK, start our virtual machine. So this is how we add new virtual disks to the virtual machine. Please note that we just added 3 virtual disk files to our virtual machine, but we have not started using that extra storage in our Linux server. Next, we are going to utilize that extra storage in our Linux server using LVMs. Next, we'll learn about logical volume management to create physical and logical volumes. So what is logical volume management? Logical volume management, or LVM, is a feature by which we can do most of the file system management activities online. Like say you want to resize the file system or add some space or extend a file system, you can do that online if your file system is based on LVMs. To explain about the logical volume management, let's go through this picture which will explain the hierarchy. Say your server has two disks, disk 1 and disk 2. We can create partitions on disks. Say disk 1 has two partitions, partition 1 and partition 2. So on top of those two partitions, we can create physical volumes. Say we create physical volume 1 on partition 1 and physical volume 2 on partition 2. Similarly, on disk 2, we have only one partition, that is partition 1, and on top of that partition, we create another physical volume 3. So we have 3 physical volumes in our server. Now on top of these physical volumes, we can create volume groups. Say we create volume group 1 on top of one physical volume, and we create the volume group 2 on top of two physical volumes, physical volume 2 and the another physical volume 3. Please note that volume groups can expand across multiple physical volumes. Now, in the fourth level of this hierarchy, we can create logical volumes using the volume groups. We can create multiple logical volumes on top of volume groups. Here, for example, we are creating logical volume 1 on top of volume group 1. We create logical volume 2 on top of volume group 2 and logical volume 3 again on top of volume group 2. So this volume group 2 has two logical volumes. Now on top of the logical volumes, we can create the file systems. Say logical volume 1 is hosting one file system called file system 1. Logical volume 2 is hosting another file system called file system 2. And the logical volume 3 is hosting another file system called the file system 3. Let's first start a terminal window, and to give it a more server-like look, we will change the background color to black. Colors, uncheck this, close. Now first check the disk devices that we just added and make partitions or physical volumes on those disks using fdisk command. To do that, first let's go to the device directory and check for sd star. You can see that under device directory we have the standard disks like SDB, SDC, SDA, SDA1, SDA2, etc. So SDA1 and SDA2 are two partitions on the disk SDA, which was created initially when we create our first virtual machine. The 3 virtual disks that we added today represented by these 3 devices at the bottom, SDB, SDC and SDD. Now let's take the first one, that is SDB, which has a size of 1 GB. Fdisk device SDB. Press M to get a help on all the commands available under fdisk. So we are going to create a new partition, type N and enter. It's going to be a primary partition, so default is P. Partition number will be 1, default 1. And the first sector will be 2048 by default. And the last sector by default will be the ending sector of the disk, that is 2097151. Press enter and print the partition table P, and our first partition, that is SDB1, has been created. Now to make this permanent, we will press W, that will write the partition table. Until you press W, these changes are in memory and will be lost. So now that change is permanent. Now we'll do the same thing for the second disk, that is fdisk dev SDC. Print the partition table, nothing will be there. We'll create a new one by pressing N. It will be a primary partition, default P. Press enter. Partition number will be 1 by default, again press enter. The first sector will be 2048 by default, press enter. And the last sector. Now here we are not going to take the entire disk for this partition, the first partition of the second disk. We'll take only half of the disk size, that is 1 GB for the first partition, and the remaining 1 GB we will take to create the second partition on this disk. So we don't know what sector number will be there, so we will specify the size instead. So we'll put plus 1 G, press enter, and then we'll create another partition. And so we have one primary partition already created, and we still have space to create 3 more partitions. So we'll create primary partition, and this time the number will be 2, that is the second partition. The sector number by default, it is selecting the 2099200. Let's take that, and the last sector it is taking by default, and we will press enter there, and our second partition is also created. Now let's print the partition table, and we see there are 2 partitions created in the SDC hard disk, that is SDC1 and SDC2. Now to make these changes permanent, we'll press W, press enter. So we have now one partition created in the first disk that we added with the name SDB, and we have created 2 partitions in the disk we created with the name SDC. To see them again, when we are in the device directory, do an ls lrt sd star, and we can see that for SDB we have a physical volume or a partition SDB1, and for SDC we have 2 physical partitions, 2 physical volumes or partitions with the name SDC1 and SDC2. For SDD, that is the third disk we created with 10 GB in size, we have not created any partitions yet, and we'll take care of that later on. Now to use the LVM, that is the logical volume management, we have to install a package called System Storage Manager. Once we install this System Storage Manager package, we'll get a command named SSM, and using that single command we'll be able to do almost all of the logical volume management activities. Please note that there are individual Unix level commands available to work with the logical volume management, like creating a physical volume, creating a logical volume, extending logical volume, etc. But instead of remembering all those individual commands, we will work with only this single SSM command, which will give us everything we need to manage the logical volumes. Now we'll go for installing our System Storage Manager package. Clear? To install System Storage Manager, we'll use the yum. So yum install System Storage Manager, and it will ask for a confirmation. Press Y, press Y again, and our SSM package has been successfully installed. Our entire LVM layout it will give us using the SSM list command. So you can see now, first of all, it's listing the devices. SDA, the first hard disk with 50 GB in size, it has 2 partitions. SDB, that has 1 partition, 1 GB in size. SDC, it has 2 partitions. First one is 1 GB, and the second one is a little below 1 GB, or you can say 1023 megabytes. And the third device, that is the SDD, is not yet partitioned. Now we have one pool. This pool is nothing but a volume group. As we explained earlier, a volume group is based on 1 or more physical volumes. So this pool OL has only one device, and that device is nothing but this SDA2 partition created on our first disk SDA. Please note that this volume group or the pool was created automatically when we install Oracle Linux in our virtual machine. Now in the volume details, we can see that on the volume group or the pool OL, we have 2 logical volumes created, dev OL root, dev OL swap, and SDA1 is not under this pool. it's a separate partition used for booting the system, or it's a boot partition. Now we are going to create a volume group or a pool using these two physical volumes that we created, that SDB1 and SDC1, using SSM command. So the command will be SSM add -p, that is the physical volume group. The name will be the Oracle, and the physical volumes that will be used to create this group or the pool will be dev SDB1 and dev SDC1. Press enter, and the volume group or the pool VZ Oracle successfully created. Next, we'll learn how to create a file system using LVMs. Now we'll create a logical volume on this volume group VZ Oracle, and also we'll create a file system on that logical volume, and we'll mount it in a mount point or a folder or a directory called U001. All these steps will be taken care by one SSM command. Let me first type in the command, then I'll explain how it is working. So SSM create -s, the size will be 1.9 GB -n LV Oracle -fs type -fs type xfs pool will be our only pool that we created, VZ Oracle 001. Now SSM is the main command. It is going to create a logical volume of size 1.9 gigs. The reason behind my selection of 1.9 gigs is because we are going to use the volume group VZ Oracle, which is based on these two physical volumes, and the size of these two physical volumes together are around 2 GB, a little less than 2 GB in size, and that's the reason I have selected 1.9 GB as the initial size of this logical volume. You can select any size which is less than or equal to the size of the volume group or the pool which is used by the logical volume. So LV Oracle is the name of the logical volume. --fs type means the file system type that is going to be created is of XFS type. --pool, that is what volume group or the pool will be used to create this logical volume, that is the VZ Oracle, and it will be mounted on U001 under root directory. So you don't have to pre-create this U001 directory because this SSM command will take care of everything. Press enter. It will ask for a confirmation to create the directory U001. Press Y and it is done. Now clear, and we'll take a look at our logical volume layout. This is the logical volume that we created, that is LV Oracle on top of the pool or the volume group VZ Oracle. The size is 1.9 GB, file system XFS, file system size 1.89, free space 1.86, it's linear, and it is mounted on U001. Now you'll be able to see this file system using df-h, and you see that this logical volume is there, and our file system is based on this logical volume. Now please note that we have not made this change permanent, because this file system will go away if we restart our virtual machine or the server. To make this file system permanent, we have to make an entry in the HCFS tab file. To do that, we will create a line in the HCFS tab which will represent this file system. We will make a copy of this first line, paste it, and change the name. If you forgot the name, simply you can open another window, a new tab. A new tab is added to the same window. We'll do a df -h to enlist all our file systems. Copy this name, which is representing the file system on top of our logical volume, and paste here in the last line. Mount point will be U001, type will be XFS. Let all other settings be the default, and then we will save it. Now, to see if file system that is mounted on U001 is consistently there, we will reboot the server. -R0. After the reboot, we'll open a terminal window, and we will see what file systems are available. And we see that our file system that is mounted on U001 is available. So our change is permanent. With the topics covered today, I would like to conclude today's video, and we'll cover the remaining topics in the subsequent videos in this series. So viewers, I hope you liked the video and found it useful. And if you did, please hit the like button and subscribe to my channel for similar educational videos to come in the future.